Something extraordinary and terrifying is happening right now beneath the Aegean Sea. A volcanic system that has been silent for 400 years just detonated without warning, and the shockwave is traveling directly toward one of the most visited islands on Earth. Scientists are detecting signals they have never seen before, signals that suggest this is not an isolated event, but the opening move of something far larger. Santorini, the island that gave birth to the legend of Atlantis, may be standing on the edge of its own destruction. February 28, 2026. 4:47 in the morning, local time. Seismographs across the Aegean network flicker and then explode with data. Scientists monitoring the Hellenic Unified Seismological Network in Athens stare at readings that make no sense. A magnitude 4.9 earthquake has just detonated on the seafloor northeast of Santorini. The epicenter sits directly above Columbo, a submarine volcano so dangerous, so primed with pressure, that volcanologists have quietly considered it the single greatest unmonitored volcanic threat in all of Europe. Within minutes, a second tremor strikes, magnitude 4.2, then a third, then a fourth. In less than 90 minutes, 17 distinct seismic events ripple outward from the same location, each one originating from depths between 2 and 8 kilometers beneath the ocean floor. The pattern is not random. The pattern is systematic. For the scientists watching the data cascade across their screens, the pattern is terrifying. By 6:15 in the morning, the Hellenic Survey of Geology and Mineral Exploration issues an emergency bulletin. Columbo submarine volcano is in a state of accelerating unrest. Monitoring buoys positioned above the crater begin transmitting thermal anomaly data. Water temperatures at the seafloor vent fields spike 14 degrees Celsius above baseline in less than 2 hours. Something deep beneath the Aegean has woken up, and it has been sleeping for 400 years. Emergency coordination calls begin between the Greek Civil Protection Authority, the European Mediterranean Seismological Center in France, and volcanological institutes in Italy and the United States. Scientists who have spent careers warning about Columbo now face the moment they always feared. The submarine volcano that sits just 6.5 kilometers northeast of Santorini's coastline is no longer dormant. It is active, it is escalating, and it is directly connected to the same volcanic plumbing system that produced one of the most catastrophic eruptions in all of human history. Most people have never heard of Columbo. That is precisely what makes it so dangerous. While Santorini's own volcanic caldera draws millions of tourists every year, with dramatic cliffs, iconic white buildings, and sapphire blue waters, Columbo sits invisible, submerged. Building pressure in the dark. Columbo is a submarine stratovolcano. Its crater rim lies just 18 meters below the ocean surface. Its base extends down to 500 meters of water. Inside that crater sits one of the most chemically volatile hydrothermal vent fields ever studied. A boiling chemical reactor of carbon dioxide, hydrogen sulfide, and sulfur dioxide, with concentrations so extreme that robotic submersibles deployed by researchers have had their sensors overwhelmed within minutes of descent. The last time Columbo erupted was 1650. That eruption killed 70 people on Santorini's northeastern coast and sent a tsunami crashing across the Aegean. The explosion was heard as far away as Constantinople. The death toll reflected a world of small fishing villages and wooden boats. Today, that same coastline hosts luxury hotels, cruise ship terminals, and tens of thousands of tourists arriving every single week. Dr. Paraskevi Nomikou, a marine geologist at the University of Athens who has spent over a decade mapping Columbo's interior, described the volcano's structure in stark terms during a research briefing in 2024. The crater walls are unstable. The vent field is operating at temperatures exceeding 220 degrees Celsius. The carbon dioxide concentrations are so high that a rapid degassing event, a sudden release of dissolved gas from the hydrothermal system, could produce a lethal cloud capable of asphyxiating marine life across a wide area and potentially creating a wave of deoxygenated water moving toward shore. But it is not just the chemistry that alarms scientists. It is the geology beneath it. Columbo and Santorini do not operate as separate volcanic systems. They share the same deep magmatic source, the same reservoir of molten rock that fed the Minoan eruption 3,600 years ago. One of the largest volcanic explosions in the last 10,000 years feeds both systems today. When Columbo moves, Santorini's own caldera pays attention. And right now, Columbo is moving faster than at any point in recorded history. At the Institute of Geodynamics in Athens, Dr. Kostas Papazachos reviews the incoming seismic data with the expression of someone who hoped they would never see these numbers. The harmonic tremor signatures appearing on the monitoring network are not surface noise, and they are not aftershocks from regional tectonic activity. They are the unmistakable acoustic fingerprint of magma in motion, fluid rocks surging through underground conduits toward the surface. The numbers are staggering. In the 48 hours following the initial February 28 seismic swarm, monitoring stations recorded over 340 individual earthquakes above magnitude 2.0. 61 of those exceed magnitude 3.0, 11 exceed magnitude 4.0. This level of seismic output represents a 900% increase over Columbo's average activity baseline recorded across the previous decade. Ground deformation data compounds the alarm. GPS receivers installed on Santorini's surface as part of the European Plate Observing System began detecting inflation. The island is swelling, not by millimeters, by centimeters. The northeastern sector of the Santorini caldera, the side facing Columbo directly, shows the most pronounced movement. Tilt meters installed near the ancient Minoan eruption site recorded accelerating uplift of 2.3 centimeters in 48 hours. That rate is 8 times higher than anything recorded during the last major Santorini unrest period in 2011 and 2012. Sulfur dioxide readings arrive from aerial monitoring aircraft dispatched by the Greek Meteorological Service. The numbers stop the room cold. Columbo's vent field is releasing an estimated 4,200 tons of sulfur dioxide per day. 4 weeks ago, that figure sat at 180 tons. The increase is 23-fold in less than a month. Every volcanologist in the room recognizes what a number like that means. It means a massive fresh supply of magma is actively degassing beneath the sea floor. It means the deep reservoir is not holding. It means pressure is building faster than the system can contain it. Oceanographic sensors detect a hydrothermal plume rising from Columbo's crater and extending 4 kilometers northeast across the seafloor. Water temperatures across the plume measure 27 degrees Celsius above ambient. The plume is visible on satellite thermal imaging as a ghostly bloom spreading across the dark Aegean water. Scientists at the National Observatory of Athens convene an emergency working group. Their conclusion, delivered in a 2-page internal briefing, does not mince words. Columbo is exhibiting pre-eruptive behavior consistent with imminent volcanic activity. Here is what has scientists most alarmed. Columbo is not behaving alone. The seismic network stretching across the entire South Aegean volcanic arc is lighting up in ways that suggest the disturbance is far deeper and far more connected than a single submarine volcano experiencing isolated unrest. Santorini's own caldera, the enormous submerged bowl at the island's center, the remnant of the catastrophic Minoan eruption, is showing signs of sympathetic activation. The 2 volcanic islands inside the caldera, Nea Kameni and Palea Kameni, which last erupted together in 1950, are recording micro-seismic swarms that track almost perfectly with the pulses of activity at Columbo 6 kilometers away. Every time a significant tremor radiates from Columbo's direction, instruments on Nea Kameni register a response within minutes. Dr. Michelle Parks, a volcanologist with the Nordic Volcanological Center who has been monitoring the Santorini system remotely since 2010, describes what the data suggests in terms that emergency planners find deeply unsettling. The 2 systems appear to be communicating through a shared deep crustal reservoir. Pressure increases at Columbo are being transmitted through the same magmatic plumbing network that connects to Santorini's caldera. We are not watching one volcano. We are watching one system with two outlets. The historical record makes this even more alarming. Geological surveys of the seafloor surrounding Santorini reveal layers of volcanic deposits that tell the story of coordinated eruptions across the Camini Line, the northeast trending volcanic chain that includes both Columbo and Santorini's internal vents. In 1950, Nea Camini erupted. Columbo showed elevated seismic activity. In 1650, Columbo erupted catastrophically. Geologists studying sediment cores from that era find evidence of simultaneous increased activity across the caldera. The pattern repeats across centuries. When one part of the system activates, the rest of it responds. And then there is the Minoan eruption itself, the event that may have contributed to the collapse of the Minoan civilization 3,600 years ago, that sent tsunamis across the entire eastern Mediterranean, that deposited ash layers found as far away as Egypt and the Black Sea. It was the eruption that produced the Santorini caldera as it exists today. Volcanologists have long believed that eruption was preceded by a prolonged period of escalating seismic and volcanic activity across the same arc that is now waking up. Scientists do not say that history is about to repeat, but they do not rule it out. And right now, they are watching the first chapters of a very familiar story begin to unfold. Santorini's permanent population is approximately 15,000 people. In peak tourist season, that number swells to over 200,000. February is the low season. The island is relatively quiet, the cruise ships less frequent, the hotels running at partial capacity. There are still an estimated 20,000 people on the island right now. And every single one of them sits inside a geological hazard zone with evacuation options that emergency planners privately describe as deeply inadequate. The island's geography creates a nightmare scenario for mass evacuation. Santorini is essentially the remnant rim of a collapsed caldera. The famous clifftop villages, Fira, Oia, Merovigli, perk on the edge of sheer volcanic walls that drop hundreds of meters directly into the sea. The roads are narrow, winding, and in many places, single lane. The airport handles limited capacity. The port sits inside the caldera itself, directly adjacent to the active volcanic islands of Nea Camini. Greek Civil Protection has issued a Level 2 alert for the Santorini prefecture, the second highest classification in their 5-tier system. Residents are advised to prepare emergency kits and avoid the northeastern coastline facing Columbo. Ferry services between Santorini and other Cycladic islands have been placed on enhanced standby, with operators ordered to maintain fuel and readiness for emergency passenger transport. The Greek Coast Guard has repositioned 2 vessels to the area. The alert level has not triggered mandatory evacuation, not yet. For the roughly 300 residents of Oia, the clifftop village that sits closest to the Columbo side of the island, that distinction feels increasingly abstract. Local business owner Nikos Papadimitriou describes standing on his terrace at dawn, watching the water northeast of the island shimmer with an unusual turbulence. He can smell something faint and acrid that was not there last week. His family has lived in Oia for 4 generations. He has never smelled anything like it before. Volcanologists watching Columbo are worried about more than lava. The specific chemical and geological characteristics of this submarine volcano create threat scenarios that go far beyond what most people imagine when they think about volcanic eruptions. The first threat is a phreatomagmatic explosion. What happens when rising magma contacts seawater at shallow depth? The interaction is instantaneous and catastrophic. Water flash vaporizes. The steam expansion is explosive, and the resulting blast carries tremendous destructive energy in all directions through both water and air. The shallow depth of Columbo's crater rim, just 18 meters below the surface, means that any significant magmatic intrusion reaching the upper crater zone would immediately contact water. The resulting explosion would be dramatically more powerful than an equivalent subaerial eruption. It would generate a tsunami. Tsunami modeling conducted by researchers at the Aristotle University of Thessaloniki and published in 2023 estimated that a moderate phreatomagmatic eruption at Columbo could generate waves reaching 6 to 8 meters in height along Santorini's northeastern coast within 4 to 6 minutes of the initial explosion. 4 to 6 minutes. That is not enough time for a meaningful evacuation of the low-lying coastal areas. Amudi Bay, one of Santorini's most popular destinations, sits at sea level directly in that wave path. The second threat is carbon dioxide. Columbo's hydrothermal system is saturated with dissolved carbon dioxide at concentrations that represent a limnic eruption risk, a sudden catastrophic release of gas from the water column. The same phenomenon killed 1,700 people at Lake Nyos in Cameroon in 1986, when dissolved carbon dioxide erupted from the lake's depths and suffocated everything in the surrounding valley. Columbo's vent field produces carbon dioxide at concentrations that exceed the levels at Lake Nyos. A major degassing event triggered by volcanic activity could release a lethal invisible cloud across the ocean surface and potentially carry on shore depending on wind conditions. The Greek Navy has issued a maritime exclusion zone extending 3 kilometers around Columbo's crater. Fishing boats and pleasure craft have been ordered clear. 2 oceanographic research vessels, the Aegean and a vessel from the Hellenic Center for Marine Research, are stationed at the outer edge of the exclusion zone, monitoring continuously. Their sensor arrays track water chemistry, temperature, and seismic activity in real time. The data they are transmitting back to shore shows no sign of deceleration. The Greek government is walking a knife's edge between public safety and economic catastrophe. Santorini generates an estimated €2 billion annually in tourism revenue. A full mandatory evacuation order, even a temporary one, would trigger immediate cancellations across the entire summer booking season, potentially costing the Greek economy billions in a nation that can ill afford another financial crisis. Government officials are under enormous pressure to avoid language that sounds alarmist. But behind closed doors, the pressure runs the other direction. The Hellenic Survey issued a private briefing to the Ministry of Climate Crisis and Civil Protection on February 27, 2026, recommending that evacuation planning move immediately to active preparation status. The briefing described the current volcanic unrest as exhibiting characteristics inconsistent with a simple stress release swarm. It specifically flagged the sulfur dioxide escalation and the caldera inflation data as requiring urgent reassessment of alert level thresholds. Prime Minister Kyriakos Mitsotakis convened an emergency session of the National Crisis Management Committee on the morning of February 28, 2026. Scientists from the Institute of Geodynamics, the National Observatory of Athens, and international consultants participated via secure video link. The session ran for 3 hours. No public statement has been issued as of this broadcast. Sources familiar with the discussion describe a tense disagreement between officials prioritizing economic continuity and scientists insisting that the window for orderly voluntary evacuation may be narrowing. The evacuation challenge is genuinely severe. Moving 20,000 people off a small island with a single airport and limited port capacity in an organized fashion requires hours under ideal conditions. If the situation deteriorates rapidly, if a major seismic event damages the airport runway, if a tsunami warning activates with minutes of notice, if the port inside the caldera becomes inaccessible, the options collapse dramatically. Emergency planners across Europe watching the Santorini situation are raising the same uncomfortable question. Is the Greek government prepared to make a difficult decision early enough for it to matter? Scientists monitoring Columbo are asking a question that extends far beyond Santorini. Is what is happening in the South Aegean an isolated event, or is it the first visible signal of something larger moving through the geological plumbing of the Mediterranean basin? The timing is deeply unsettling. In March 2025, the ground beneath Pozzuoli in Italy tore open an 8-kilometer crack connecting Campi Flegrei, Europe's supervolcano, to Mount Vesuvius. Italy raised volcanic alert levels to their highest classification. In January 2026, Mount Mayon in the Philippines entered its most intense period of unrest in 15 years, with sulfur dioxide emissions climbing to 5,530 tons per day. Now, just weeks later, Columbo is showing eruption precursors in the Aegean. 3 volcanic systems, 3 separate regions, all escalating within the same 12-month window. Volcanologists are careful about drawing connections between geographically distant volcanic systems. The science of teleseismic volcanic triggering, the idea that a major seismic or volcanic event in one region can activate dormant systems elsewhere, remains actively debated. But the data accumulating from the Mediterranean arc is giving even cautious researchers pause. The Hellenic volcanic arc, which includes Columbo, Santorini, Milos, and the volcanic field stretching northeast toward Turkey, shares deep crustal connections that are only partially understood. Mount Etna in Sicily recorded its highest lava fountain frequency since 2013 during January and February 2026. Seismic networks beneath the Aegean detect what researchers describe as deep, long-period earthquakes, the type of low-frequency tremor associated with fluid movement at depths of 15 kilometers or more. These events are occurring not just at Columbo but at multiple points along the volcanic arc simultaneously. Dr. Ioannis Kasaris at the Geodynamic Institute describes the pattern as a reactivation of the deep arc system. The question is not whether individual volcanoes are responding to each other. The question is what they are all responding to. 1 week from now, Santorini's situation may look very different. The seismic swarm may quiet. The sulfur dioxide numbers may plateau. The inflation signal may stabilize. It has happened before. The 2011 and 2012 unrest period generated real alarm before gradually subsiding without an eruption. Scientists will tell you that volcanic systems are extraordinarily difficult to predict, and that elevated unrest does not guarantee an imminent eruption. But they will also tell you that the numbers coming out of Columbo right now are unlike anything in the modern monitoring record for this system. 4,200 tons of sulfur dioxide per day, 340 earthquakes in 48 hours, 2.3 centimeters of caldera inflation, a hydrothermal plume spreading kilometers across the sea floor. These are not the numbers of a system releasing pressure and settling down. These are the numbers of a system that is loading. In Evacuation, shelters that Greek authorities are quietly pre-positioning in Crete and the mainland, cots are being laid out. Ferry operators are receiving non-public advisories about standby protocols. A volcano that buried towns in 1650, that sits 6 kilometers from an island of 20,000 people, and that shares its magmatic roots with the eruption that may have ended an entire civilization, is exhibiting behavior that has scientists checking their instruments twice and their escape routes once. The Aegean has always lived with its volcanoes. The same geological forces that created Santorini's impossible beauty. Those blood-red cliffs, those caldera sunsets that draw visitors from around the world are the same forces building pressure beneath the seafloor right now. 400 years of silence is ending. The only question that remains, the question that that scientists cannot answer, and that 20,000 people on a clifftop island are living inside, is what comes next, and how much time is left to prepare for it.